Hello everyone, welcome back to Senior Classroom. Today we're diving into a topic that's absolutely crucial for anyone working with databases, SQL Query Optimization. So, why is SQL Query Optimization so important? Well, think of it as fine-tuning the performance of your database. Optimized queries mean faster execution times and efficient resource utilization. In today's video, we're honing in on Microsoft SQL Server. Whether you're a seasoned DBA or just starting out, these optimization tips will help you enhance the performance of your SQL queries in an MS SQL environment. Now, let's talk impact. Well-optimized queries not only make your applications run smoother, but they also ensure your database operates at peak efficiency. And you know what that means: a happier user experience and better overall system performance. Without further ado, let's jump into the fascinating world of SQL Query Optimization. But before we do, make sure to hit that subscribe button and ring the notification bell so you won't miss any of our future content. Now, let's get started. First technique is always specify select fields. Avoid select star statement. When writing SQL queries, it's a good practice to be explicit about the columns you want to retrieve rather than using the select star statement. The select star statement selects all columns from a table, but specifying the exact columns you need can significantly improve query performance. Selecting only the necessary columns reduces the amount of data transferred between the database and the application, improving query speed. It minimizes the workload on the database server by fetching only the required data, resulting in faster query execution times. Next is use top to sample query records. When dealing with large datasets, it's often unnecessary to retrieve the entire result set, especially during development, testing, or when analyzing data. The SQL top clause is a handy optimization tool that allows you to sample a specific number of records from the beginning of a query result, improving query efficiency and response time. Key benefits are efficiency in data exploration. When you're working with a large dataset, using top lets you quickly preview a subset of records, making it easier to understand the data structure and content. Faster testing and development. During application development and testing phases, you may not need to fetch all records. Employing top helps speed up the testing process by providing a representative sample of data. Reduced network load. Fetching only a portion of the result set reduces the amount of data transferred between the database and the application, resulting in quicker response times. Next is avoid too many joins. When writing SQL queries, the number and complexity of join operations can significantly impact performance. The optimization strategy here is to judiciously limit the number of joins to only those necessary for retrieving the required data. Excessive joins can lead to increased query execution times and may strain the database server. Key considerations are performance impact. Each join operation adds computational overhead to the query. Too many joins can result in a substantial increase in the time it takes for the database engine to process and return the results. Maintainability. Queries with numerous joins can become complex and challenging to maintain. Simplifying join structures enhances code readability and makes it easier for developers to understand and troubleshoot queries. Resource utilization. Excessive joins may lead to increased consumption of system resources, affecting the overall performance of the database server. It's essential to balance the need for data retrieval with the impact on system resources. Next is avoid using select distinct. While select distinct is a powerful tool for fetching unique values from a column, it can be resource-intensive and impact query performance, especially when applied to large data sets. The optimization strategy here is to consider alternatives and use distinct judiciously to prevent unnecessary processing overhead. Key considerations are performance impact. The use of select distinct can lead to additional work for the database engine, requiring it to identify and eliminate duplicates from the result set. This process can be time-consuming, particularly when dealing with large datasets. Alternative approaches. In some cases, achieving the same result without using select distinct is possible. Utilizing group by, proper indexing, or restructuring the query may offer more efficient ways to obtain unique values. Resource utilization. Reducing the reliance on select distinct can help conserve system resources, ensuring better scalability and improved responsiveness of the database. Next, use wildcards at the end of a phrase only. When using the like operator in SQL queries, especially when searching for patterns in text columns, it's a good practice to place wildcards at the end of the search phrase. This optimization ensures that the database engine can take advantage of indexes more effectively, leading to improved query performance. Key considerations are index utilization. Placing wildcards at the end of a phrase allows the database engine to use indexes efficiently. This is particularly important for large datasets as it reduces the amount of data the engine needs to scan. Prefix search optimization. By placing wildcards only at the end of the search string, you enable the database to perform a more optimized prefix search. This is beneficial for queries where you're looking for values that start with a specific sequence of characters. Performance impact. Using wildcards at the beginning or both ends of a search phrase may lead to full table scans, which can be resource-intensive. Optimizing the placement of wildcards helps mitigate this impact. Next technique is avoid using multiple OR in the where clause. When you need to combine two or more conditions, it is recommended to eliminate the usage of the OR operator or split the query into parts separating search expressions. SQL Server cannot process OR within one operation. Instead, it evaluates each component of the OR, which in turn may lead to poor performance. Key considerations are complexity impact. Multiple OR conditions within the where clause can introduce complexity, potentially leading to suboptimal query plans. This complexity may result in increased query execution times. Index utilization. Complex OR conditions can make it challenging for the database engine to fully utilize indexes, impacting the efficiency of data retrieval. Optimizing conditions can enhance index utilization, readability, and maintainability. Simplifying the where clause improves query readability and maintainability. It makes the code more straightforward, facilitating easier understanding, debugging, and future modifications. Next is add missing indexes. In the world of databases, indexes play a crucial role in optimizing query performance. Indexes are data structures that act like a roadmap, enabling the database engine to quickly locate and retrieve specific rows of data. By strategically creating and utilizing indexes, you can significantly improve the speed and efficiency of information retrieval in your SQL queries. Key considerations are speeding up data access. Indexes function as a way to quickly locate the rows that meet specific criteria in a query. This results in faster data access, especially when dealing with large datasets. Reducing query processing time. Indexes allow the database engine to skip scanning the entire table, leading to reduced query processing time. This is particularly beneficial for select, where, and order by clauses. Improving overall database performance. Well-designed indexes contribute to improved overall database performance by minimizing the resources required for query execution. This can result in enhanced responsiveness and scalability. How to apply this technique? Identify key columns. Identify columns frequently used in where clauses, join conditions, or order by statements. These are often good candidates for indexing. Understand query patterns. Understand the typical patterns of queries executed against your database. Create indexes that align with these patterns to maximize their impact. Consider composite indexes. For queries involving multiple columns, consider creating composite indexes that cover those columns. This can further optimize query performance. Next is check for unused indexes. As databases evolve, the necessity of indexes can change over time. Some indexes that were once beneficial may become unused or redundant. One of the reasons for that might be implicit data type conversion. Regularly assessing and removing these unused indexes is a crucial optimization technique that helps maintain a lean and efficient database structure. Key considerations are reducing storage overhead. Unused indexes consume storage space, contributing to increased disk usage. Removing these indexes helps reduce storage overhead, freeing up resources for other database operations. Improving write performance. Indexes incur maintenance costs during data modifications, inserts, updates, deletes. Unused indexes add to this overhead without providing corresponding benefits, potentially impacting write performance. Enhancing query performance. Focusing on relevant indexes ensures that the query planner makes optimal decisions. Eliminating unused indexes improves the accuracy of the query planner, leading to better overall query performance. Let's consider the following query. During the execution of this query, SQL Server will perform implicit data type conversion, converting int data to varchar before comparing. In such cases, indexes won't be utilized. How can this be avoided? We recommend using the cast function, which converts a value of any type into a specified data type. Let's explore another example. In this scenario, implicit data type conversion will occur and the indexes won't be utilized. To address this, we can optimize the query as follows. Filtered indexes can impact performance as well. Consider having an index on the employee table. However, this index won't function as intended for the following query. To leverage the index, optimize the query in the following manner. Minimize the use of subqueries. Subqueries, or nested queries within a larger query, can be powerful tools, but excessive use may impact query performance. This optimization technique focuses on reducing the reliance on subqueries, aiming to streamline and simplify queries for improved efficiency. Subqueries, or nested queries within a larger query, can be powerful tools, but excessive use may impact query performance. This optimization technique focuses on reducing the reliance on subqueries, aiming to streamline and simplify queries for improved efficiency. How to apply this technique? Evaluate query structure. Review your queries to identify areas where subqueries are used. Consider whether these subqueries are necessary or if there are alternative ways to structure the query. Use joins or derived tables. Where possible, replace subqueries with join operations or derived tables. This can lead to more efficient execution plans. Optimize where clauses. Instead of using subqueries in where clauses, explore the use of exists, in, or join conditions to achieve the same results with potentially better performance. Example: consider a query with a subquery to find the average salary of employees in a specific department. Optimize the query using a join. Next is use union, all instead of union. When combining the results of multiple select queries, the use of union is common. However, if you can be certain that duplicate rows won't be present or don't need to be eliminated, opting for union. All instead of union can significantly improve query performance. Key considerations are: performance impact. Union removes duplicate rows from the result set, and this process incurs additional computational overhead. If duplicates are not a concern, using union all avoids this extra processing, resulting in faster query execution. Reduced resource usage. Union all is more efficient in terms of resource usage as it doesn't require the database engine to perform the additional step of identifying and eliminating duplicate rows. Scenarios for union. Use union when you specifically need to eliminate duplicate rows from the combined result set. If duplicates are acceptable or unlikely, using union all is a more efficient choice. Next is optimize subquery performance. Subqueries are powerful tools in SQL, but their performance can vary based on how they are written and executed. Optimizing subqueries aims to enhance their efficiency, contributing to overall query performance. How to apply this technique. Review subquery structure. Examine the structure of your subqueries to identify areas for improvement. Consider whether a different type of subquery or a different approach, such as a join or exists clause, might be more efficient. Indexing. Ensure that the columns involved in subqueries are indexed appropriately. Indexing can significantly improve the performance of subqueries, especially when dealing with large datasets. Limit subquery results. If possible, limit the number of rows processed by subqueries. This might involve using limit offset or top clauses or adding additional where conditions to reduce the result set. Example: consider a correlated subquery to find employees with salaries above the average for their department. Optimize the query using a join to achieve the same result more efficiently. The optimization approach may vary based on the specific characteristics of your data and the database management system you are using. Next is avoid running queries in a loop. RDBMS are designed to handle set-based operations efficiently. Performing queries in a loop introduces unnecessary overhead and may result in increased processing times. Executing queries in a loop often involves multiple round trips between the application and the database, leading to increased network latency. Set-based operations can reduce the number of round trips, improving overall query performance. How to apply this technique. Batch processing. Where possible, design queries to operate on batches or entire datasets instead of individual rows. This may involve using joins, update statements, or other set-based constructs. Avoid cursors in loops. Minimize the use of cursors or similar constructs that iterate through result sets row by row. Instead, consider alternative set-based approaches. Bulk operations. Utilize bulk operations or bulk insert or update statements when dealing with large datasets. These operations are optimized for set-based processing. Example: consider the following loop-based approach to update salaries. Optimize the update operation using a set-based approach. Next optimization technique is avoid over-indexing a table. Over-indexing occurs when a table has an excessive number of indexes, potentially more than what is necessary for optimal performance. While indexes are valuable for speeding up query retrieval, having too many can lead to increased storage requirements, slower write operations, and additional maintenance overhead. Example: consider a scenario where a table has individual indexes on columns, column 1 and column 2. Optimize by using a composite index. The decision to create an index should be based on the specific query patterns and requirements of the application. Next is use appropriate data types. Choosing the correct data types for columns in your database tables is a fundamental aspect of database design and optimization. This technique encourages the selection of data types that align with the nature of the data being stored, ensuring efficient storage and enhancing query performance. Next optimization technique is use varchar instead of char. When defining character columns in a database table, selecting between varchar and char depends on the nature of the data. This optimization technique encourages the use of varchar for variable length character data when the length of the stored values varies, optimizing storage space and improving overall performance. Char columns allocate a fixed amount of storage space for each value, padding shorter values with trailing spaces. In contrast, varchar columns only store the actual length of the value, leading to more efficient storage. Next optimization technique: use stored procedures. A stored procedure is a precompiled set of one or more SQL statements that are stored in the database and can be executed with a single call. Utilizing stored procedures provides various benefits for optimizing SQL operations. Stored procedures are executed on the database server, reducing the amount of data that needs to be transmitted between the database and the application. This can significantly minimize network traffic, especially for complex operations. Stored procedures promote code reusability since the same logic can be invoked from multiple parts of the application. This can lead to a more modular and maintainable code base. Next optimization technique is table partitioning. Table partitioning is a database design strategy that involves dividing a large table into smaller, more manageable partitions. Each partition typically contains a subset of the table's data, and this division is based on specific criteria, such as ranges of values in a particular column. The primary goals of table partitioning are to optimize query performance, simplify data management tasks, and enhance the overall efficiency of database operations. Key considerations: improved query performance. Partitioning allows the database engine to access only the relevant partitions when executing queries. This targeted access can significantly improve query performance, especially when dealing with large datasets. Efficient data maintenance, data loading, archiving, and purging become more efficient with table partitioning. Instead of managing the entire table, these operations can be performed on individual partitions, reducing the impact on the overall database. Enhanced data availability. Partitioning can improve data availability by allowing for more efficient backup and restore operations. Backing up or restoring individual partitions is quicker than dealing with an entire table. For example, consider partitioning a large sales table by date ranges. The exact syntax and capabilities for table partitioning may vary depending on the database management system. Next optimization technique is use temporary tables. Temporary tables are tables that are created and used for a short period, often within the scope of a session or a specific query. These tables can store intermediate results, perform complex calculations, or break down a complex query into simpler steps. The use of temporary tables can contribute to improved query performance and simplified query logic. Consider a scenario where you need to calculate the average sales per customer for the last month. Using a temporary table can simplify the process. By using temporary tables, you can streamline complex query operations, improve performance, and simplify the overall logic of your SQL queries, especially when dealing with multi-step or intricate data manipulations. And that brings us to the end of our video on optimizing SQL queries. We've covered essential techniques, highlighting the importance of streamlining your code for efficient database performance. If you found these insights valuable, don't forget to hit the like button, subscribe for more content, and share this video with your fellow developers. Your support means a lot. Happy querying, and I'll catch you in the next one.